So we're going to be looking at the quiz review for the equations and inequalities quiz coming up for 7th grade. The reason that this is sometimes bundled together is because the method for solving an equation and the method for solving an inequality are very similar barring one rule. Everything else is done the exact same way except for one tiny twist for inequalities, so usually we can do them together. But we'll start with equations here just to make sure we review that. So to solve for an equation, remember I usually like to draw a line down the middle just so that you have two clear sides. That way when I say move to the left or move to the right, you know what I'm talking about. So the goal in solving an equation, remember, is to get the variable by itself. And in inequality too, you want to get the variable by itself. So when you're solving for something, you want to get that target something by itself, which means you want to move every other number away from that variable. So in this case, solving for x, I want to move the 5 and the 4. Now, the way you do this is usually you get rid of anything that's being added or subtracted, or basically anything that's not attached to the variable directly, get rid of that first, and then get rid of the number that's attached to the variable. So get rid of anything you can add and subtract first, and then get rid of the variable. So for instance, I'm not going to move this 4 right now. I'm going to try to move this 5, because what kind of 5 is this? It's a positive 5. It's not multiplying to the x, that means it's being added to the x. So how do I get rid of a positive 5? I'm going to subtract it. Now this makes this go away, which is good. I should always have one of the things cancel, and then I have 4x left over. And then here, this is going to be negative 32. Because negative 27 minus 5 is negative 32. So remember, whatever you do on one side of the equation, you have to do on the other. That's the golden rule for equations, is whatever you do on one side, you have to repeat on the other. So if I minus 5 here to get rid of that, I have to minus 5 here to get rid of that. Now this is 4 times x. This is different. 4 times x. So how do I get rid of times? Again, you do the opposite, so you divide. In this case by 4. Not by 4x. We don't want to move the x, we just want to move the 4. So this goes away. I'm left with x. And then negative 32 divided by 4 is negative 8. And so there is my answer, x equals negative 8. Now, if you want to check that answer, what you can do is plug negative 8 in for x and see if it works. So remember, our equation was this: 5 plus 4 times x is equal to negative 27. If you want to see if you got it right, 4 times negative 8 is negative 32. Negative 32 plus 5 is negative 27. So that works out. You don't have to check it, but if you have time, it's not a bad thing to do. Number 2 is the same way. Subtract the 2 because it's positive to move it to the other side. So you have 7 times x is equal to 51 minus 2, which gives you 49. Now the reason I'm not subtracting the 7, the reason I'm dividing by the 7 is because even though there's a plus here, that plus doesn't mean that the 7 is being added to the x. The 7 is still multiplying to the x. So you have to think about, what is this number doing to the x? In this case, the 7 is multiplying to the x, so I get rid of it by dividing. Same thing here. Divide by 7, and you get x equals 7 itself. These are all solved the same way. So once you get the hang of 2 of them, you can pretty much do all of them. Same thing here. Subtract that 9. Subtract the 9. And then I'm going to have 3x left over because, remember, you always want to write down what you have left over after each step. So 3x. And it is good to write down each step you do. That way, if you do make a mistake or you get lost, you have a trail to kind of fall back on. If you just try to do this all in one go, you might be able to get through with it, but you're very liable to mess things up. And then 24 minus 9 is 15. Then we divide by 3. And we get x equals 5. And that is a 3 there. X equals 5. So once again, write down every step of your work. That way, if you mess up or if you get lost, you have something to fall back on. Now, this one's a little different because this is minus 7. So this 7 is a negative number. It's not multiplied to the x, so it's a negative 7, so I get rid of it by adding 7. Because it's the opposite of minus or negative is adding. So I have negative 3x equals, now this is 0. And some people freak out because they don't want to write down 0 because they think 0 is nothing, so therefore they don't have to write anything down, so they're kind of lost because they lost an entire side. But no, 0 still counts as a number, so you still write it down and you still keep your sides very strict and very structured. Negative 7 plus 7 is 0, so you write down the 0. And then you divide by the negative 3 just like you normally would. Divide by negative 3, divide by negative 3. and you get your answer of x equals 0, which is a perfectly okay answer. Sometimes x can equal 0, but you have to write it down. You will always have two sides. You will never magically lose one side. You will always have to maintain two sides, even if one of them becomes 0, which they can, and that's fine. The last two here are inequalities. Now, as I said before, solving inequalities and solving an equation is almost the same thing except for one minor twist in some cases. So I still put the line down the middle. I still get rid of my addition and subtraction numbers first. So minus 1, I get rid of it by adding 1. Again, nothing's changed so far. I'm doing the exact same procedures as I did with an equation. So 7x is greater than or equal to 84. Notice how I keep the same symbol I have at the beginning. And then I still get rid of the 7 by dividing it because it's being multiplied to the x. And I get x is bigger than or equal to 12. And there's my answer. So in this case, nothing's different except I just keep the symbol in the middle rather than the equal sign. By the way, don't accidentally change it to an equal sign because some people do, because it is very similar to solving an equation. Make sure you keep it the same symbol it has been. Now, the next one's the one with the trick in it. So this one has a little bit of a twist. Start the same way. Add 1 to both sides. All good. Negative 5x is less than 35. Now, here's where the trick comes in. I divide by negative 5 because it's being multiplied to the x. But whenever, and this is the golden rule, whenever you divide or multiply by a negative number with an inequality, your middle symbol is going to flip direction. So if I divide by a negative 5, my middle symbol is going to point the other way now. So it'll be x is bigger than negative 7. If I had to multiply by a negative 1, then my symbol would flip as well. Now, the trick is that this only happens when you multiply or divide by negative. If you add or if you subtract, your symbol would not flip. If I divide by a positive number, my symbol does not flip. The symbol only flips when you multiply or divide by a negative value. It's very strict in when it happens, so make sure you keep in the back of your head to look out for it, but don't overuse it as well, because that's just as bad. And on the back side here, we have two word problems. So a gym membership requires a one-time fee of $25 and an additional $10 every month. This is how much you've paid. How many months have you had the membership for? So remember, one-time fees or starting values is stuff that's added to the variable. So I have let's say m here for months. So I'm adding this 25 to the m because it's a one-time cost. So I know I'm going to have to add a 25. $10 every month. So this word here, every, or for each, or for every, this usually means I'm multiplying the value to the variable. So whatever number repeats every single instance, so every month, every year, every hour, every doll, whatever it is, anything that repeats over and over and over, that's multiplied to the variable. And then the number that you end up with a total amount of, that's what goes on the other side. So this is how I would make the equation. One-time cost of $25, $10 every month, and then $155 in total. And then I solve it just like I did on the front side. Subtract 25 from both sides. We get 10m, because this goes away, is equal to 130. If I didn't make a mistake, which I don't think I did, divide by 10, and you get m is equal to 13. So you've had the membership for 13 months in total. So the trick here is remember that the one-time cost is being added, the repeated cost is being multiplied. Now sometimes you might end up with some negatives in your word problems. So you cut off 3 inches from a 20-inch piece of lumber with every chop. When you finish, the lumber is 8 inches long. How many chops did you make? So it's a little bit trickier. So chops, we're going to do C for chops. You cut off 3 inches from a 20-inch piece with every chop. So 3 inches every chop. That's a repeated number. 3 inches every chop. So 3 is going to be with the C, and it's 3 inches off. So you're losing the 3 every time. You're cutting off 3 inches every time. So that's a negative 3 with the C. from a 20-inch piece of lumber. So that means that you started with 20 inches. So that means I'm going to add 20 because it's the starting amount. It's something that happens once. I start with 20 inches, I lose 3 every chop, and at the end, my total amount is 8 inches when I'm finished. So how many chops did I make? Well, we go ahead and solve it like we would an equation. Minus 20 from both sides. We get negative 3c is equal to negative 12. And then divide by negative 3, and we get c is equal to 4. So he made a total of 4 chops to get this desired length, taking off this much from each chop. So be careful with the negatives because they can be very subtle sometimes. So if I'm cutting off something or if I'm losing something, then that's a negative number that I put in. So if it was a addition, it'd be a subtracting number. If it's a multiplication, it's just simply be a negative number. So with the word problems, just read them carefully, make sure you put the numbers in the right spot, and you'll be just fine. And then remember that rule for inequalities is if you multiply or divide by a negative number, then you flip the sign. Anything else you do, you keep it the same. So it's a very rare case. Just make sure you're on the lookout for it and don't overuse it. Hope you enjoyed the video. Have a good day.